Alright, I know this is what I gave you for homework the other day. I'm going to run this through, and this is for those of you who've gone on here after I've recorded it. And guess what? I'm going to give you some answers. Okay? So, first thing we're going to do on, excuse me, on number one is I'm going to show you that what we want to do initially is we want to set both of them up for this y equals mx plus b. Okay? So what we do is we want to take this equal sign and cut it apart and say, okay, set both sides equal to y. So the first one we're going to say is, and I'm going to use some different color here, is y equals 2 times the quantity of 3x plus 4. And then I'm going to set up the quantity y equals negative 4. Alright? So doing that, we want to see what is our intersection point. Okay? What point satisfies both of these equations? Okay? That's the whole concept of why we set these two expressions equal to each other. All right? And if we solve this, yes, we can go excuse me. All right? We can go 2 times 3x plus 4 equals negative 4. And then if I use my steps that we talked about today, I distribute out, I get 6x plus 8 equals negative 4. I subtract 8 from both sides, and I get 6x equals, because these cancel out, negative 12. Divide both sides by 6, and I get x equals negative 2. Okay? So we'll write that right over here. Let's see here. If I say x equals negative 2, all right, let me erase this portion of it, okay, that we did, and we'll start from over here, because now that we don't really need a table for this, okay, we actually want a graph, okay, and we know that if you notice right here, since y equals negative 4, you're going to see something that right there that basically our coordinate pair that we're looking for better be something like that, okay? And it should be, our coordinate pair is going to be negative 2, negative 4. That is the one point that satisfies both. And you're going, well, what does that mean? Well, let's find out, okay? So let's build us a graph. Okay, let's see here. Normally I should have probably put this on, brought up a picture of it, but that's okay. We can do it from here. All right, so if I take this and I say, okay, fine, I want to plot the first one, y equals negative 4. So if I go 1, 2, 3, 4, and I draw a line that kind of goes through there, okay? Oh, that should have been green, okay? Let me go back and get rid of that line, and we'll go, the green one goes right through there, okay? That is this y equals negative 4. That is the line for it, okay? So then if we graph the x, or y equals 2 times 3x plus 4, okay, well, we have to put that in that y equals mxb form, so we need to solve for, get rid of our parentheses, y equals 2 times 3x is 6x plus 8. That is the y equals mx plus b form, okay? Here's our m, here's our b, all right? Remember, b tells us where to start at, okay? So we go, starting on the y-axis at the origin, we go up 1, 2, 3, 4, 5, 6. Not going to get it there, so let's kind of break this apart. You're still going to be able to see what we're talking about. All right, so let's go with 8. 1, 2, 3, 4, 5, 6, 7, 8, okay? So I'm going to be able to put a red point right there, okay? Now what I want to do is, if that's 6, let's just see what happens if, let's just find another point. And remember, if we take our slope, okay, and remember our slope is the difference of y over the difference of x, or rise over run, okay. Now if I take that 6 over 1, okay, because that's 6, and any number can be put over 1, That means I can either go up 6 and to the right 1, or I can go down 6 and 1 to the left. Okay? And you'll understand what I mean maybe later on about this. But if I do this, if I do the second type, I can actually keep that on the graph, okay? Because otherwise I got to go way up high. So let's go 6 down from that point and 1 to the left, okay? Because basically I made that -6 and -1. It's still -6 divided by -1 is still 6, okay? So now that I have that, I can actually create my line that runs up through those. So what are we looking for? We are looking for this point right there. And that point should be, okay, and I know it kind of looks like, well, that's going to be kind of weird, expanded, but it's just because I'm freehanding this. If I actually had a graph, okay, then that would work out. This point is -2, -4, okay? And I'll see if I can put a graph on one, and we'll go from there. All right, but that is the crucial point, and basically what it means is if I take -2, put it back in my first equation, that means 3 times a -2, because I'm putting it right here, okay, putting -2 in there. 3 times -2 is -6. -6 plus 4 is a +2. Oh no, -6 plus 4 is a -2. 2 times -2 is -4, and that's what we have right there. Okay, so I put this in, and I got this out. All right, and that's exactly what you're supposed to do. What about the other equation? Okay, so if x is -2, guess what? Y is always -4. It doesn't matter on this one. All right, so let's go with that and see if you can complete 2 and 3. I'll tell you what. I know this is 7 minutes long. I'm going to erase all of this, and I'm going to do number 3 for you real quickly. Okay, first off, let's go ahead and distribute both sides out, and I'm going to do this again in red for the left. We have 3x plus 2x minus 5, and that means I can combine like terms, and I make this equal to y, and it doesn't matter if you really put it on either side, but since I'm already started right in there, I can't really get in, I can't get back here, so, alright, so that's why I put the y over on that side. Doesn't really matter. But then this can actually be rewritten as, by combining like terms, I have y equals 5x minus 5. Alright? So I'm stopping with that. And let's take the other side. And I'm going to set it equal to y. And I'm going to say y equals 13 minus 2 times x plus 2. And I go, okay, that's fine. We can do that. Y equals 13 minus 2x, using distributive property, minus 4. Well, when I combine all that up, I get y equals -2x, and I have a positive 13 and a -4, so I have a positive 9. All right, so here we go. We got a graph to do, and I've got to be able to get to the -5 on my y-axis and a positive 9. So let's see if I can build this in here, okay? Let's see here. See if I can do this fairly straight, okay? All right, now, if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, we might as well go 10. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I try to do the same 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. All right, we'll go with that, and we'll see if we can reach it. All right. So if I take my red one, and it says 5x minus 5. Now remember, to start graphing this, I start with, if you remember the thing I'd always talked about, y equals triangle over square times x plus circle, and circle always tells us where to start. So that means this is where we need to start. So I go to -5, all right, and I'm going to switch to red, so I'm going to go 1, 2, 3, 4, 5, and I'm going to put a dot there. Now my slope says 5, and that means it's 5 over 1. So I go up 5 over 1 to the right, because both of them are positive, and here's my line. No, let's try that again. We'll try one more time. Close enough. Okay? Now what I want to do is I want my green one, and I go y equals negative 2x plus 9. So I go up here to positive 9, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, and I put a green dot. Okay? So I now have a green dot there, and my slope means I have negative 2 over positive 1. Now, it doesn't matter whether this is negative 2 or positive 1 or positive 2 over negative 1. They still mean the same thing. And I'll show you what I mean. I'm going to plot both of these points, or using that rise over run. I'm going to use the first one. It means I go down 2 and 1 to the right, and it's here. The other one, just putting in another mark here. The other one, if I went up 2 and 1 to the left, I'm start here and I go up 2 and 1 to the left. Guess what? It puts it where basically it's still on the same line. And that kind of shows how as long as you keep the signs, change them together, it doesn't really matter. Okay, we can talk about that in class tomorrow. Let's see if I can draw this line in here. Yeah, close enough. All right, so now I have an intersection point somewhere around here. Now, it's pretty close probably to 2, right? All right, so I'm going to take all this information, and I'd really like to have extra room to do it, but that's okay. I'm going to set my two equations up, and I'm going to, let's do this. I'm going to get rid of all this, okay? And I'm going to get rid of this. That'll give me a little bit of room. Let's get rid of some of that. Okay, so now if I set these equations up, since both are equal to y, I just set them equal to each other, and I have 5x minus 5, and that equals, and I'm going to change to green, negative 2x plus 9. All right? So if we do those two, I'm going to now switch to black just so that it shows that I'm working them together. I'm going to add 2x, gives me 7x on the left side, and these cancel out. And then I'm also going to, since I have my x's on the left, I'm going to add 5 over here, and I'm going to add 5 over here, so I can get rid of the constants on the right, because this will cancel out. And this equals 9 plus 5 is 14, so x must equal positive 2. Aha! And that is somewhere along this line right in there. And that looks pretty doggone close. Boy, that's pretty good. 1, 2, 3, 4, 5, 6. And let's see if we come out around 6. So now I can take that x equals 2, and I can plug it into either one of these. It's not quite at 6, but I can tell what's going to happen now. I'm going to use the red one, and I'm going to go y equals 5 times the quantity of 2. Okay, that's my x equals 2, minus 5. And I solve this, and I get 2 times 5 is 10 minus 5, so y equals 5 when x is 2. All right, 1, 2, 3, 4, 5. Well, my spacing might be a little bit off, okay? But basically it's saying it's somewhere in here, okay? And if that mark was spaced up properly, that right there, the coordinates for that are 2, 5. So let's find out. We can actually plug that coordinate pair into both equations and see what happens. Well, we already know that it works for the red because that's how we got the 5. Right? So let's see how it works for the green. If I take this 2 and I plug it in here, I get negative 2 times a positive 2 gives me a negative 4 plus 9 gives me a positive 5. Okay? So this is the solution I'm looking for. All right? That's what we're looking for when it says give the intersection point as a coordinate pair. Okay, so there, you've got 1 and 3, so now you just have 2. Little secret for those of you paying attention. All right, I'm going to go ahead and go over the next page, and let's see here. I'm going to quickly do a couple of these. Oh, yeah. Number 4 is just a beast, but it's one of those, if any of you have paid attention in science class, you'll see what happens. It says, in her science class, Kathy is required to convert temperatures she collected in degrees Fahrenheit into degrees Celsius. Teacher has said that the degrees Celsius equals 5/9 of the difference. It says 5/9 times the difference between the degrees Fahrenheit and 32. All right. Hopefully you guys saw how to do that. This is the general equation for converting Celsius to Fahrenheit. Fahrenheit to Celsius. Okay. Now I'm going to actually add C to it, and it says if Chuck measured his temperature in 55 degrees Celsius, what would it be in Fahrenheit? So what we need to do is, let's take this equation, and I'm going to rewrite it up here. And I'm going to convert it from Celsius to Fahrenheit. So let's erase this one. Okay. Now, first thing I want to do is I want to get f by itself, but I'm looking at my fraction out here. I'm going to multiply both sides by 9, okay, because of this 9 right there, okay? So if I multiply this by 9, and I multiply this whole thing by 9, because I'm multiplying here, I'm simply going to just basically get rid of that denominator on the right side. So I'll have 9 degrees Celsius. Let's do this. Go 9 degrees Celsius equals 5 times F minus 32. Okay? So I'm going to do this. I want to divide by 5. Okay? I'm just doing this on the outside. Normally, whatever you're dividing by is going on, on the other side, but because of room, I'm going to put it here. Okay? So I'm going to have 9/5 of Celsius equals Fahrenheit minus 32. So now to solve, I just add 32. Add 32. And I can take, and I'm going to flip the whole thing at one shot because this cancels out. And I'm going to go Fahrenheit equals 9/5 Celsius plus 32. And then if I drop his 55 degrees into there, all right, let's see if I can still fit it in here. I'm going to go 9/5 times 55 plus 32. And I'm going to ask you to finish that off. All it is multiplying 55 times 9. No, I'm not. I'm going to do it even easier. This and this cancel out, and that makes that 11. I have 99 plus 32, and that equals, what is that? 131 degrees Fahrenheit. Okay? And that's my answer. It is 131 degrees Fahrenheit for 55 degrees Celsius. All right, there, I did the hardest ones for you, and so from there, I want you to try to figure out the rest of them. Good luck. We'll talk about it in class.